So welcome everyone to the Fluence second workshop of the Hack the System hackathon. Thank you all for joining tonight, and hopefully we have some people from the previous workshop as well, but if not, I believe Evgeny is going to be giving a kind of introduction to Fluence presentation quickly before we head into the more technical stuff later on in the event. So do we have, I see we have Alexey and Anna, and do we have Evgeny here as well? If so, just pop your screens on so we know you're here. But in terms of the hackathon in general, we're now in week 4 of the hackathon, which is coming towards the end of the education piece. So if you haven't yet started building your project, I'll begin to start thinking about that this week and next, as we have the final few workshops. Perfect, we have Evgeny here. And in terms of upcoming events after the Fluence workshop today, we have the one with Polygon next week, who used to be called Matic. And after that, we have Stella's second workshop, and finally the CoinMarketCap and Sandbox game other workshops as well. So without further ado, I'll hand over to the co-founder of Fluence, Evgeny. Thank you very much for joining us this evening.
Hello, hey everyone. Thank you for coming. Thank you for giving me this this introduction talk. So I will try to just briefly explain what Fluence is and why we are doing this and why it's so cool before Alexey follows you through the workshop. Just a reminder for anyone who missed our first workshop. So first of all, for this workshop, just check you will need npm or yarn installed, and also Docker and Git. And I believe there is a link to the Notion page with the workshop detail right now in the chat. So feel free to go there, and while I'm talking, just check out what's going to be happening after. And also there will be Rust and WebAssembly needed, but Alexey will explain how to install it properly if you don't have it in the system yet. Okay, so what is Fluence? At Fluence, we are building the decentralized analogy to clouds, basically. So we create the peer-to-peer development stack that allows you to create any kinds of applications or backends with avoiding proprietary cloud tooling or centralized servers or centralized clouds. So when you develop in your application, you fully rely on open source tools and open source stack that Fluence provides. And using this stack, you can create all kinds of from end-to-end peer-to-peer applications to traditional distributed systems and deploy it back to the cloud, but not being really dependent on their managed services or their proprietary SDKs and so on. Also, using Fluence Stack, you can compose different APIs, services, data sources, and I will also, without reliance on something proprietary, I will show you some examples of it. And soon, when we have the blockchain layer, you will be able to monetize some stuff that you created that other people using in the network. So they're going to be the common network, they're going to be the blockchain, they're going to be payments. So some people will be able to host services for other people. So it all will start working as a decentralized hosting network. And right now, because there is no blockchain yet, there is no incentivization or ability to pay other people to host services. You can create applications, but you will be able to, you'll make sure that you are hosting backend services by yourself, or you know exactly who hosts your backend services. So you cannot just rely on the network to provide you some guarantees about availability of services that you created. And if you think of like what you're trying to achieve here, similarly to how DeFi enabled composability for financial tools and components, we are trying to create the common medium of composability of backend stuff. So you can create different backend services, maybe like a blockchain oracles, APIs, some data sources, compose them together and use them in a common networking execution environment. So the more services created in the network, the easier and faster to create new applications, similarly to how composability works in DeFi. So you can create more complex DeFi applications on chain using the components that were created by other people. Same things here, but off chain and soon to be on Austin Marketplace. And at the core of the Fluence stack is the Aquamarine programming language. And this is the new programming language that we created to program peer-to-peer applications and distributed systems. It based on the theory on PyCalculus and basically allow you to create all kinds of, to express all kinds of business logic in terms of distributed services composability, in terms of programming how your application has to be executed from service to service, from peer to peer. Similarly, how you usually use Amazon Lambda, for example, when you compose in different microservices in the cloud. So you're saying, I want this user request to go to this service and then execute this function, and then go back to me, and then go to the second service and execute second function, and then put some data to database. Similarly, Aquamarine allows you to do that, but without any centralized place where all the scripts are executed. Scripts are being attached to data packets, and they go to the network and being executed by the network step by step. And it allows you to create everything from simple request response to complex networking algorithms like BFT consensus, Raft, gossip protocols, like any kinds of networking protocols can be programmed using Aquamarine. And the second thing is services. Fluence has services similarly to microservices, but services in the Fluence, they are WebAssembly based. So they have all benefits from WebAssembly, sandbox. They're fast and their size not huge. It's not a Docker, not a huge Docker containers. It's like a really small WebAssembly based services. They are composable over the network via Aquamarine. They can contain some state. They can be fully stateless, so it can be just some function that calculates you something and lives somewhere in the network on some node. And they are extendable with external data. So you can, when you create a service, you can connect it to external data sources, to APIs, or to decentralized storage. For example, you create in the chat application that sends messages between browsers, but also saves the messages history into the decentralized storage. So you can create a plugin to IPFS or Skynet or Arweave or anything else, and use Fluence stack connected with this external storage and store the data there. So the data availability will be provided by this protocol, and your application logic will be executed by Fluence network. And this obviously works for blockchain data. So you can connect to blockchain, for example, to Ethereum. You can read data from Ethereum, and you can do something, whatever you need in your application with blockchain data. And so Aquamarine is intended to be the high-level programming language that you can see on the right, but it's not ready yet. So we have the intermediary representation of Aquamarine that we call AIR. And it looks like a Lisp-style language on the left, but it's not so hard. So if you're not creating huge and super complex algorithms, it's pretty easy to program AIR scripts. And Alexey will show you a couple of examples during the workshop. Also, few things. So like currently what you can do is this air.
Sorry, Evgeny, we can't hear you, or is it just me?
No, it's same for me. I couldn't hear either.
Yeah, we've lost the sound.
Let's hope we don't have a Vega situation.
Oh no.
Can someone tell them he's not speaking?
Okay, maybe now I have sound.
Yeah,
there we go.
Perfect.
Yeah, much better.
Great.
Yep, sorry guys. So what you can do is AR today. You can connect peers, you can discover peers, you can call functions on the peers, you can deploy services to different nodes, and you can do all kinds of networking stuff. So you can set up loops of requests, you can execute them in parallel, you can handle error and get error back to the peer that started the execution of error script, and you can have authorization, you can have custom authorization for your application to allow some peers to write into your services and some people not. And so you can find all of this in the documentation. And finally, what you can build with Fluence, and I'll give you a couple of examples. So you can think of anything like from end-to-end peer-to-peer applications like chats, collaborations, like online collaboration, real-time collaboration, gaming stuff that works without backend and just uses network to relay messages, to connect your browser peers and relay messages between them. You can, for example, create something very different, which is like a blockchain, like the Oracle system for blockchain. You can use Fluence Stack to create oracles and to deploy them to some nodes and to read data, to subscribe to data from the chain, and so like use all of this tooling to create Oracle system. You can potentially create the applications that are governed and run by community. And what does it mean? It means that currently when the application has a backend and backends live in the cloud, someone should have the admin, credentials of this cloud. So they're always the person that can switch off the backend of the application. And our hosting marketplace basically allows you to, and the stack itself allows you to build application the way that backend services can be run by many community members. And if you design your application properly, then basically any user can open the front end of your application, which will call one of backend services being hosted by one of community members, and then it would work. So if one of backend services will go down, there are others that can be used to serve the business logic. And it's all can be connected to DAOs on chain, for example, if you want. So it can really go much more comprehensive. And you can create any kind of network algorithms, some distributed system stuff. If you want to play with air, you can think of any kind of consensus systems or messaging protocols. And so a couple of examples, we have the example of code collaboration application that uses that connects peers in real time, and it's the analogy of CoderPath application. So you can go to our GitHub and check the repository and see how it was built. And we have the network dashboard, which at the same time is the AIR-based application, which uses AIR requests to gather data from the network. And finally, bounties. We have 3 bounties for this hackathon. First 2 really, really simple, and everyone who builds them can get the bounty. So if you use AIR in any your application, you get the first. If you use AIR and deploy AIR a service
to the network, you get the second, and best applications get top bounties. And you can see more details if you follow this link about the bounties. And that's it from me. Alexey can just continue with the workshop.
Hello, can you please allow me to share the screen?
Let me. Okay, that should do it. Awesome.
Okay, great. Thank you, Evgeny, for introducing Fluence. So what's gonna happen today? On the previous workshop, I went in really details of how to develop services and how to deploy them to the network. Today, I'm gonna focus on how to develop services locally, how to run your own node to connect to the network. So you can see the logs, you can see the output you could be missing from the other tools, other means. And that's basically it. It's going to be pretty short, but I hope you will enjoy. And again, for more detailed explanation on how to develop services, you can refer to the previous workshop. It's available down here below in the links. Let me scroll. Here, the recording of it and the scenario here in the Notion too, so you can follow. Okay, scrolling up. So we'll start with setting up the environment. I hope you already have npm or yarn, docker, and git installed. This I would not cover. What I will cover is setting up the Rust and cargo and stuff, and then setting up Fluence tools. So let's start with setting up the Rust. It's pretty easy. You just have to copy this command and paste into your terminal. And then it will ask you, and you will just press 1, and it will do in a few minutes. That will work. That will install you Rust nightly toolchain with ability to compile Rust to WebAssembly right away. So yeah, after installation is done, you would need to either reopen your terminal or execute the following command in your terminal, and you can check then that the cargo is available by, well, executing cargo -- version. So I hope you're starting doing that in the background. And in another tab, we can begin setting up the Fluence tools. First one is FLGist. It's a tool to interact with the Fluence network, to deploy services, to inspect them, to execute air scripts, and this is your go-to CLI tool to work with the Fluence network that you should use to manage your services and inspect them and stuff. So installation is pretty simple. You just need to call npm install globally on this package. So you just the same, you paste it to your terminal, hit enter, and it will be installed. And then you can check that it has been installed via FLGist -- help. You will see the different options available. Let me make it bigger. It's really a lot of them here. So you can do a lot of things with the network. You can upload modules. You can inspect modules on the on the nodes of the network. You can get interfaces of your services. You can create services. And that's basically it. And you can, of course, execute scripts with FLGist. I will show you how to do that, but first we need it installed. Okay. So another two tools we need to have installed to follow the workshop are fcli and frepl. This will allow you to build WebAssembly in a correct way with correct types and different metadata built into WebAssembly modules, so you can deploy it to the Fluence network. Also, you will need a FREPL. This is you won't need for this current workshop, but overall it's a useful tool, so you can develop your services locally without deploying them anywhere. It's as easy as previous one. You just copy paste it in your terminal and it installs. You can check then that it's installed by printing FC version, and it should be fine. You can know that fcli and fc are different. That's how it works. So mind that. And the final step we need to do is to copy the examples repository. You can do it like you usually do copy the Git repositories. It's pretty simple. So you copy, either this line if you're authorized in GitHub through HTTPS, or this one if you're using SSH keys for authorization. Okay, I will give you a few minutes to be sure that you can follow.
We have a question in chat, Alexey, if you want to take that in the meantime.
Mm-hmm.
Sergey's asked how long till the Fluence blockchain layer is ready, and does that mean that until then applications won't be decentralized?
Mm-hmm. Evgeny, do you want to answer that one?
Yeah, I did it already in the chat. So the idea is that because there is no incentivization yet, the network works similarly to how IPFS works and how IPFS provides you guarantees. If there is no nodes in the network on IPFS who will host your file, then it will just disappear if you don't host it by yourself. So the same thing in the Fluence network. So you can deploy your service on some available nodes, but you don't have any, like a fundamental guarantees that this node will continue to serve your services until you do it yourself, at least at one node. And this is why I talked about example of community-run applications. So if you have a community, you have several people who committed to be hosters of your application backend, you basically can achieve this decentralization goal using this way. But after the blockchain layer exists, you will be able to have some, you will be able to pay people for hosting it, so you'll have more guarantees. I hope I answered.
Thank you. So I hope the installation more or less complete. Once again, if you want to follow the workshop and copy paste, what kind of cool hack projects have been built previously on Fluence? We have a repository of examples. Let me show you. Here it is. And here you can see all sorts of applications and examples you can start with. You can see here, there's example projects, so you can kick off your hacking. You can see here the integration with Ethereum. You can see there an analog of Bloom filters. You can see here how to integrate with IPFS, how to use our WebAssembly port of SQLite. And really, there are a lot of things to dig on and to learn about Fluence. So this is a good start. And as Evgeny mentioned before, we have a FluentPad project. This one has a more rich backend, front end. So you can refer to this one too. It's pretty user-friendly. So I think this could be also a great example. Okay. So let's start with running a local Fluence node, so we have a node to deploy something to. We can just paste this here. We can also pass arguments here, so we can see what are the possible options for this. Let me just update. If you ever find yourself, if you have used the Fluence node before, you can always update it by using Docker pull. That's a good thing to do because we deliver releases pretty often and it changes pretty often. So if anything doesn't work for some reason, you always should start with Docker pull first, or ask a question right away in the Discord. So yeah, you can see that there is a new option available. It's called local. It allows you to run a node that is not connected to the network. Can be done like this. So here we have a node. You can see its logs, and it shows you that if you have any troubles, you can do Docker pull and go to our discussions or to Discord to ask questions. A few interesting thing you can see here also is the peer ID of the node that we just started. You will need it to deploy services and to manage them and to call them. So it's a really important information. You can see here the version of the AIR interpreter. That's a WebAssembly module too. So everything is portable. And the very same AIR interpreter is running in the browser when you're using Fluence.js SDK. So it's the same on the node and in the browser. I think that's nice. So let's open a new tab and let's return to our workshop. So we have started a local Fluence node. Now let's check that it works. First, what we'll do is we will create a simple AIR script that does really almost nothing. Besides, it's telling the network to go to the relay node and then to take the result back to the client. The role of the client plays FLDist. So FLDist is the client here, and relay is our node. This construction means that we just copy pasting this code to the file under the name script AIR. So we just select this, paste into the terminal, and then we select this. So what we just done, I have created a file script AIR. It contains the script of 2 lines. Go to the relay, save hello as a variable under the name result, and then send this result to the client, to the init peer ID. So it's this is the ID of the initiator of the script. So whoever would run this script, he would receive the result back. And the result is a variable that contains a simple string hello. It's a really easy example. To execute the script, we will use FLDist run AIR command. We would need to specify path to the script and address of the node. By default, it uses address of the node in the network, but here we want to use address of the node of our local node. That's why we specify here our local host. And here we specify a local host, then we specify port. We say that you should expect WebSocket on the port 49s. And this way we specify the peer ID of the node. So it works as a public key. This way we have our connection to the node secure and encrypted. The peer ID can be found here in the logs of the node. So let's copy paste that command up to here. Okay, and then we can just insert the peer ID. And let's see if it works. So what happened? I have executed the command, so I sent this script to the network. You can see that some metadata is printed, and you can see the ID of the script, of the particle with the script, but that doesn't matter. What matters is that we have received the result back. So this script has worked. We asked relay to generate us some data and send it back to us as a result. So here we have our result. You can see that it's wrapped in array, just like here. Okay. And also we can see that, let me repeat that again. So we can see the logs. So here we can see the node, that the node received this particle and executed the script. You can see that we have executed the op identity operation. It basically means return. Identity is a mathematical operation of returning back what it received. So if you call identity 1, you receive 1 back. If you call identity hello, you receive hello back. So you can see that our node executed op identity and sent particle back to us. Okay. So yeah. Now we have checked that we have a working node. If you haven't cloned the examples repository yet, it's the time to do that because we will need it right now. So let's clone it if you haven't, and let's go to the folder of the examples. Once we are in the examples repository, we should go to the curl_template folder. Here we will see a project that contains of backend and frontend parts. Right now we will be interested only in the backend part to learn how to deploy backend to our local node. If you wish to learn how to connect frontend to the backend, you can refer to the previous workshop. Okay, so the interesting, so what will happen now? We need to deploy the service. How that works? Let's see. Here we have a deploy.sh script that does all the work, but if we don't know what's inside, that's not interesting, right? We need to know how it works to understand how the deployment process works in the Fluence network. So what's happening here? First, we have some checks that everything is installed, like FC and default dist. Then what we do, we go to the backend folder and we call fc build ---- release. What this tool does is it builds the Rust project and outputs a WebAssembly file. Let's do that manually. First, let's go to the backend. And we can see that it's a simple Rust project. It contains cargo TOML with little dependencies. Let me show you. It depends on the Fluence Rust SDK, and we have a new version for it. And that's it. And we can take a look at what's inside of this service. It has only one file. only main file, because it's a pretty simple service that does what it does. It goes to the URL and returns the result. So it queries a given URL and returns you back a result as a string. And that's basically it. So yeah, back to deploy SH. Here we have command to build the backend. We can paste it here and it will build. We can find here WASM file. Here it is. It was built. And what happens next? We check here in the script that this WASM really exists, or we print error. And then we call FLD's new service command to deploy the service on the network. Here you can see that we are also referring to some backend config.json. Let's review it so we can understand what's happening there. Here we can see this is the configuration file for the service. We specify here the name, it can be anything. And we also specify mounted binary. So when we saw this Rust code, what it actually did, it called the binary on the host, in our case in the Fluence container, and it simply called the curl command. So it was just almost the same as if you would do it by hand. So if you do something like this, it will return the results. And that's exactly what's happening here in the Rust code, except that it's in a sandbox. And the only way to get access to the curl command is to explicitly give permission to call the curl binary here under the name curl. So what this thing in the config does, this section, it allows service to call the curl binary. Once we have a WebAssembly file, .was module, and this JSON configuration file, we can deploy the service. But here, if we would just execute this command, it will deploy our service not to the local node, but to the actual network. So we need to add node address there to switch to the local node. So let's see what we have used previously. So we were using this address. It hasn't changed because we haven't restarted the node. So yeah, well, so we just simply add this parameter here. I put a / here so I can show you on the next line, but you can just go without it. You can just append to the end. So let's now execute the deploy sh file. Go back to the root of the curl template project. So here we in the examples /curl template, and we execute the deploy.sh. So we deploy the service to the node. You can see several calls were executed here of add module, add blueprint. Blueprint is a recipe for the service that's gets created under the hood. And finally, you can see that srv create was executed to create the service. It's all happening inside air scripts. So this really can be easily repeated manually without FLDist, but FLDist makes it easier, and you don't need to remember all the names for SRV create, dist, blueprint, and all the stuff. So it just automates the easy stuff for you. So we have executed deploy sh script, which in turn executed FLDist new service like this. And after service creation, we got back service ID. This ID is very important. You will need it you will need to know it to call services on the network. If you want to call a service, you need to know where it's deployed in the network and its service ID, so you can call it. Okay, so let's just call our service. But first, let's review the API we're going to call on the service. As I said before, it's a really simple service that all it does, it provides a request function that accepts a single string parameter and returns string result of the URL request that was performed. So since it's only one function that's available there, we will call it. To call a service, we need an air script. It's almost the same as before, except that instead of op identity, we now have service request. Here you can see that service is a variable. Everything that's not in the double quotes or person signs is a variable or instruction. So here you can see that service is a variable, so we will need to set it. And also URL is a variable, so we will need to somehow provide it to the script, to set it somehow. So what this script does, it says go to relay, call function request on this service, and pass this URL as an argument to the function. And once you get the result, put it to the result variable and return to the client. This line is the same as before. It just says that we should return the result to the client. So let's create that script the same way as before. So it worked. And now we need to call that script. First, what we need to do is to change the service ID here to the one that was created when we created the service after the deploy sh call. So we copy the service ID, we paste it here. You can see that argument, the variable URL is set to this URL. It will search through DuckDuckGo for definition of condensed milk. And also we need to change the peer ID here of node. Let me do that. So here we are. We have the full command. We just copy it. And what happened? So we executed this command. We passed correct node address. We passed argument variables as JSON object. And we provided a path to the script to execute. We sent the FLDist sent the script to the node, and the node returned as a result. So it's a simple request response topology here. As you remember, we were returning string result structure from the request function. String result structure has the following, structure. It has the following fields: error, return code, stdr, and stdout. Since there was no errors during the execution, we have only stdout field, and we have return code 0. That means success. You can return your own structure, any structure that you want, except enums can be returned from the function, and you can manipulate it directly in the script. I will show you how in a moment. So here you can see that we have exactly what has been returned by the curl, but as a string here in stdout. So you can tell that it's as simple as working with binaries, and it allows you to access external network resources easily. Okay. So maybe any questions so far? No? Okay. So basically we just executed a curl binary that queried the following URL and returned its result. It's a simple, really simple example, but since it's a general purpose platform where you can program and express any logic you want, you can build any service in Rust, and you can build many of them and compose all of them with air scripts. You can compose here. You can see that the calls are sequential, but it's possible to have them in parallel. It's possible to iterate over arrays or lists of results. So really, almost any logic can be expressed with the air scripts and Rust. Just to show you a simple example of composing services, let's compose the single service by calling it twice. So we'll do the same thing as before, except the script now is a little bit more complex. We have nested seek instruction. That means that we start sequential execution, then we start another sequential execution that takes only 2 instructions, and we execute everything one instruction after another. Here we have a language reference in the documentation. Documentation is linked in the resources section below. I will show it to you. So what we have here a call to the DuckDuckGo about the same condensed milk, and we have a call to DuckDuckGo about definition of beetroot. And here, as you remember, we have not just a string as a result, but a structure that contains stdout field, stdr, and else, and other fields. So here we can manipulate the data fields. We can access them directly in the script. So this makes it possible to have your data manipulated and changed without any central authority, since the script is attached to the packet and sent along the particles and executed by every node it meets. You can have this logic executed on the network, not on some central authority. Okay, let's paste this script to the file. Let's check that it works. Okay, great. And let's run it, except let's change those 2 things. First, we will need a node address from our previous call. Let me zoom out a little so it doesn't jump all around. So I'm using here the service ID from our deployment and the node address of the node that we run locally in the Docker container. Something went wrong. Ah, my bad. Okay. So here we have a lot of output, but the essence is the same. We have our script executed, and we have two calls there to our service on the node, and we have returned two results this time. Let me zoom out so it's easily seen that we have two abstracts here. First about condensed milk, and second about beetroot. And here you can see that all that this data was produced by stdout fields. This is actually a security metadata. I was talking in detail about it and how to secure your applications with that metadata on the previous workshop. So please refer there to know more about how to build authorized applications. So we have a composition. Here it's a single service, but it can be different service. It can be tens of services. You can compose different Ethereum oracles and calculate prices between them and take the one you trust the most and send it to your application, for example. You can really do anything you can imagine here. That's it. It's a short one this time. So let me just review resources. So as Evgeny already said, we have a dashboard. So every time you deploy the services to the node, they will appear here. They will appear in this list of services. And here, if you run your node without the -- local at the end, and you have external access to your IP address, your node will appear here too. We have a documentation that documents how to use AIR. We didn't go into much detail this time about it, but here you can read about all the instructions, all the possibilities, for example, how to handle errors when they happen, and how to iterate through the arrays in your scripts. It's pretty nice structured, so you can learn a lot about Fluence from here. And please refer to the previous workshop. It was deeper in details, and we have a recording of it there. Examples repository you already know, and if you have any questions, you can go to the Discord, in Encode Discord, or to our GitHub discussions here. And we have more resources in our documentation here, different video talks, overviews. You can see our protocol paper on GitHub. It's really nice reading. So, yeah, that's it. Thank you.
Awesome. Thank you very much, Alexey, for that fantastic presentation and kind of workshop there. Just to put in the chat, this is a link to the video and the resources from the last workshop, which was went into a bit more detail. So if you'd like to go and look at that and perhaps follow that along, feel free to follow that. In terms of the Encode Club Discord, I'll send a link to that in chat now as well. And if someone from the Fluence team would like to put the Fluence Discord as well, I'm sure they'll be more than welcome to take any questions there also. And in terms of Hack the System, upcoming events wise, we have one next week with Polygon, who previously were called Matic, and they are a layer 2 solution on Ethereum. So if if you're thinking of integrating Ethereum, but we're kind of scared of the high gas fees, feel free to come along to that workshop next Tuesday. But thanks again, everyone, for coming today. Thanks to the Fluence team, and particularly Alexey and Evgeny for their presentations. And I hope you all have a great evening.